As a continuation to the previous video on direction angles, we're looking at a two-dimensional problem that has three forces, F1, which is 65 newtons, F2, which is 50 newtons, and F3, which is 70 newtons. And for each one, I want us to find out what the direction angles are. So we know that whenever we're trying to find a direction angle, it's the angle between the force in question and the positive axis that we're thinking of. We're already showing where the positive y-axis is. This is the positive x-axis. So let's look at in terms of F1 right now. So delta x is the direction angle to the x-axis. It would be the angle between the force in question and the positive x-axis. If this is 45 degrees, then this is 45 degrees, and we know this is 90 degrees. So the direction angle would be this, 45 plus 90, so it's 135 degrees. And we could have also gone in the other direction too. We could have said theta x is also equal to 45 plus 180. So 45 plus 180 is 45 plus 180 turns out to be 225 degrees. And again, just like I said in my video on the components, this is probably the first time you've ever seen a situation where one variable is equal to two different values. Okay, now I'm going to look at the F2 force. Now, in this case, what I find easier to do is, because we know this is a vector and it's a force, I always like looking at the tail of the point that I'm coming from. So I am going to push this force out here to be 50 newtons. So I'm basically pushing it along. And if this is 30 degrees, then this is 30 degrees as well. Because it's harder to find the direction angle when you're looking at the force with the tip, the head at the point in that of the body you're looking at. So I always move this off. So in this case, what is theta x? Theta x is the angle between the force in question and the x-axis. So theta x is equal to 30 degrees. Okay, and then how about for F3? We have F3 here. It lies along the x-axis, so what is theta x going to be? It's equal to 0. Okay, now let's go back to F1 and look at theta y. Theta y would be the angle between the force and the positive axis, so theta y is going to be equal to 45 plus the 90, which again, 135 degrees. Theta y for F2, it's the angle between the force in question and the y. So we're looking at this right here. So it's 30 plus 90, which would be 120 degrees. So whenever I'm trying to find, even though theta x or theta y could have two values, I'm always looking for the one that I could calculate easiest. And then for F3, theta y, well, this is where the force is. Here's the positive y. So theta y is equal to 90 degrees. Okay. Now let's look at a three-dimensional problem. I'm going to fold the sheet back. So I'm going to give you a little bit of time to look at the problem. So this is a three-dimensional problem. We have F1, F2, and F3. And if we look at F1, where is F1? Well, let's look at what angles they give us. Here's the y-axis, here's the z-axis, here's the x-axis. So whenever there's a three-dimensional problem, we always want to see where the axes are. And the only angle that's given to F1 is this 40 degrees here. There is no other angle given. Plus, they give us these lines, which is showing you that F1 is actually on the YZ plane. So if it's in the YZ plane, let's see, theta x, theta y, theta z. So in terms of F1, the angle between the force and the z-axis is 40, so theta z is 40 degrees. The angle between the force and the positive y-axis is 90 minus 40, so it's 50 degrees. And now the question is, well, what is theta x? If F1 lies on the YZ plane, that YZ plane is perpendicular to the x-axis, so theta x is 90 degrees. Okay? All right, let's take a look. So this was for F1. Let's look at F2 now. F2 is 100 newtons. When you first look at it, you might think, wow, it lies right on the YZ plane, XY plane. But notice they didn't give you these lines like they did in F1. And they're also giving you a lot more angles. Notice there's an angle here of 60 that goes from the force to Y. There's an angle 45 that goes from the force to X. And then there's an angle of 120 to Z. So you could tell by getting those three angles that this force does not lie on the XY plane. In fact, they're giving you what theta x, theta y, and theta z are. Theta x is 45 degrees, theta y is 60 degrees, and theta z is 120 degrees. This is interesting because the other 3D problems we saw on the homework for components didn't really give you on the 3D problems theta x, theta y, and theta z. Instead, they gave you angles that projected it down to a surface. So this is interesting to look at this. So let's see now. It's 45 degrees from X. It's 60 degrees from 90. They're both acute. But it's 120 degrees down from Z, which means this force lies below the XY plane. Because it's 120 degrees, if it were lying on the XY plane, this theta Z would be 90 degrees. But because it's more, it means this rope, this force, is lying below the XY plane. Okay, and now let's do F3. Again, we're going to look at all the angles that they have here. So we have a 45 degrees to the negative y-axis. We have a 60 degrees to the x-axis, and we have a 60 degree to the z-axis. So theta x, theta y, theta z. So theta y is 60 degrees. Theta x, sorry, is 60 degrees. Theta y, theta z is 60 degrees as well. And now we're looking at theta y. Theta y, it says it's 45 degrees to the negative y-axis. So that would be 180 minus 45, which is 135 degrees, is the angle between F3 and the positive y-axis. Okay, I hope this gives you more practice in determining the direction angles.